It is no secret that we need more sustainable materials if we hope to help the planet. Bio-derived materials are one potential option, but they must be economical if anyone is going to use them. For instance, a better bio-based milk jug would be great. However, if the milk sells for $20 per gallon because the cost of the jug increases from $1 to $17, no one will buy it. University of Delaware researchers and collaborators from CanmetENERGY are keeping just this type of economics in mind as they look for ways to upcycle biomass into new products. Take lignin for example. Lignin is a component of plants and trees that provides strength and stiffness to help the flora stand up to what Mother Nature throws its way. In the pulp and paper industry, however, lignin is a waste left over from making paper products. This type of lignin, known as technical lignin, is considered the dirtiest of the dirty, something that isn't usable, except maybe to burn for heat or to add to tires as filler. About 100 million tons of technical lignin waste is generated annually in pulp and paper mills around the world. The UD researchers say this widely available resource can be much more valuable. The team has demonstrated that it is possible to efficiently turn industrially processed lignin into high-performance plastics such as bio-based 3D printing resins and valuable chemicals. An economic and life cycle analysis reveals the approach can be competitive with similar petroleum-based products too. A paper describing the new method was published in the journal Science Advances. One of the main problems with upgrading lignin is that most of the processes to do it operate at very high pressures and are expensive and hard to scale. Major drawbacks of current industrial techniques include the safety concerns, capital costs, and energy consumption associated with traditional solvents, temperatures, or pressures used in the process. To overcome these challenges, the research team replaced methanol, a traditional solvent used in lignin deconstruction, with glycerin, so the process could be done at normal ambient atmospheric pressure. Glycerin is an inexpensive ingredient used in liquid cosmetics, soaps, shampoos, and lotions for its moisturizing capabilities. But here, the glycerin helps break down the lignin into chemical building blocks that can be used to make a broad range of bio-based products, from 3D printing resins to different types of plastics, flavor and fragrance compounds, antioxidants, and more. Using glycerin provided the same chemical functionality as methanol but at a much lower vapor pressure, which eliminates the need for a closed system. This change allowed the researchers to do the reaction and separation steps simultaneously, leading to a more cost-effective system. Operating at atmospheric pressure is safer. Just as important, it also provides a straightforward route to scale beyond small batches and run the process continuously, creating more material with less labor in a cheaper, faster process.